So if this might be your second go at it, so here we go. So the first thing you need to know is your universal set, right? We usually call it U, but it's not always U. It's not always U. Sometimes it's a different letter, but that's the one outside. It's all possible elements, and it's sometimes referred to as your sample space. That's what you can draw from. A capital letter is used for sets and subsets, and braces are used to open and close that set. So an example would be, right, G for students wearing glasses, perhaps, or let's just go with number, right? You want the elements, and then it just keeps going. A set is a collection of objects that have something in common or follow a particular rule. Elements are the objects in a set, right, that are called elements. So either, let's do this. I think most of you told me I need visuals, right? So if your universal is numbers 1, 2, 3, 4, 5, let's say, okay, and let's just have one set in here, A. And so let's say we have 1, 2, 3 in here, and 4, 5 are out there. Sorry, I know it's a bit small, I apologize, but I'm going to try to make this work. Okay, so if I asked you to state A with all the elements in it, then it would be 1, 2, 3 like this. Every element must be unique, no repeats, and they need to be arranged. So every element needs to be unique and arranged. I will not take marks away if they're not arranged because the province doesn't either, but technically we should have them arranged, either alphabetically or numerically. A subset, I'm going to switch colors here just to kind of transition. A subset is a set within a set. All the objects belong to a greater set. And we use this notation. Okay, so you should have on your study sheet that is the notation for subset. And maybe have an example. A subset B means that all the elements of A can be found in B. I would say pretty much everything is very important, but subset is most definitely something that you want to have an understanding of. If even one element in A is not also part of B, then we write that they're not a subset. To determine the total number of possible subsets, we use, this is new, where n is the number of elements in the set. Note that the set itself can also count as a subset. What's going on? Okay. So here we have two sets. A is blue, green, red, and B is blue, green, red, purple. One thing that I would like to add, and this question didn't, is that technically you have a universal set here, and universal has everything that is possible. So we would go blue, green, red, and purple. Oh, sorry, black. I forgot black. Sorry, guys. Can we add black? Let's undo this. Jeez. Black, blue, green, red, purple. Like, technically, that's my universal. It's all possible, right? But here's something I want you to notice right away when I'm asking you to draw a diagram or anything like that. I want you to notice that blue, green, red, like all of the elements in A are also found in B. Okay? All elements in A are also in B. Therefore, A would be considered a subset. It's a C sideways, right? Of B. Oh, yeah. How do I fix this? How do I fix this? I promise I know what I'm talking about. Today's just not a good day. It's Monday. You know, there should always be like a 5-second delay between what I say and what you actually copy, right? I'm gonna fix it. Sorry about that. Yeah, this is black. I write black and blue. And so blue, green, red. Sorry about that. But you notice that all the elements in A are also in B. So because we know that, we can state this. We know that this is true. If you drew a diagram, can I ask you to please nest them one inside the other? So A has blue, green, red. Okay. And B is around A, right? So you would have black and purple are the elements that are only in B, right? And then you draw your box around it. You really want to make sure whenever I ask you for a Venn diagram that you have a box around it. It's a must if you want full marks. Okay? So Venn is nested. If that's even a term, I'm just making it up as I go. If you have nx, if you have the n in front, it means, so if nx is equal to 8, that means that the number of elements belonging to the set x is 8. That's what that means. So if you have an n in front of the capital letter, it just tells you how many elements are in there. How about we do this? Because you're going to look back at this and let's just put 8 elements in there. I use numbers instead of words because it's so much faster. But you could have words in there, okay? You could have names, you could have colors, you name it. And so n of x, in this case, is 8. So x itself is like you state the elements, if that's what they want. Like state the set with the elements in it. That's what they're asking for. If it's asking for the number of elements, it's n to the n of x, basically. Next, we have our infinite sets. If the set starts or ends with ... it's an infinite set. I will add a note here. It has no start and or end. It has no start and or end. Okay? So what does that mean? We could have another example here. If you have an even number, if I just tell you even numbers, it could go ... -2, 0, 2. It just never ends, right? you can have your natural numbers. Natural numbers are 1, 2, 3, whole numbers that don't include 0 and goes to positive infinity. All of these are infinite sets. They don't have a start or an end. Okay. Finite sets. If the number of elements is finite, countable, it's a finite set. So it has a start and an end. Okay. Has a start and an end. Okay. Then you've got your empty or null sets. There are no elements in there, therefore it's empty. The symbol for empty is a 0 crossed out, or just 2 empty, like brackets with nothing in it. Okay. For example, a set of odd numbers divisible by 2 is an empty set. No such number exists. And so you could do E is, if I ask you to state the elements, you would just say this. If I ask you for the number of elements in it, it's 0. Usually it's a 0 crossed out. I wouldn't care either way. Outliers, elements that are part of the universal, but are not part of any other sets. So here, let's make a little Venn diagram. Let's have a mutually exclusive set, AB, let's say. Outliers are all the numbers that are around here. In general, we'll have them somewhere floating around. Let's go to page 3. Equal sets, not so important. So I'm just going to let you read it if you want to know that one. Disjoint, important. Okay. 2 or more sets with no elements in common are said to be disjoint. Okay. Disjoint. No elements in common. They're also called mutually exclusive. So you need to be able to do this just visibly, like even and odds. It'd be 2, 4, 6, 8, let's say. 1, 3, 5, 7. There's no common element, so you can't, you scan and you're like, there's nothing they share. Or you should be able to see it this way. Evens and odds. This would be 2, 4, 6, 8. This would be 1, 3, 5, 7. If you already copied this, if you copied part of this because you watched the lesson, then just watch and see if you need to add anything, or if there's something, maybe just pay attention as I explain this. Okay, keep going. Joint sets. That's also very important. You need to know what joint sets are. 2 or more sets with at least one element in common. So for example, a set of students taking grade 12 applied and biology 40S, there could be students taking both. In fact, are there students taking biology 40S in this class? I've got 3. 3 or more, at least 3. So this would be, if we consider applied in biology, that would be a joint set. There'd be students that are taking both, right? So that's what that is like. So let's try this one. Applied. And is it like this? And Filbert? Or is it Jaren? Filbert, are you doing 40 bio? Oh, sorry, Filbert. If anybody else is, I apologize. And bio, I gotta add someone in here that isn't taking bio. Who's not taking bio? Jaren and Leah, yeah. Question? Jaren, what's your question?
So they ask for n of a finite set for dot dot dot, which is like,
If you see dot 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 at all, it's infinite.
so dot 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 in between.
In between is fine, as long as there's no dot 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 on the ends.
So what would you put as n of that finite set? If it's dot dot dot.
If it's one, if you can see the pattern that it's 1, 2, 3, 4, all the way to 49, then it's 49. Yeah. That, I have never seen that. But if it's a really big set, if your universal is from 1 to 1,000, I wouldn't expect you to write all the numbers to 1,000. I would go 1, 2, 3, 4, dot, 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 90, right? 999, 1,000. Yeah. So biology. Oops, Filbert. Okay, so in this case, you can see, right, you can see that, is it Aliyah? It's these three elements in common. So in this case, your Venn diagram would have 3 students. Let's just put 3 in there. If this is applied and this is biology, there'd be 3 students that are sharing there in both sets, okay? So that's what a joint set is. I'm gonna highlight this center because that's what we're after, okay? There's something in there. Keep going. The complement, also very important. Every set and subset has a complement. It is denoted by using a little tick or a bar above it, okay? So considering our universal from 1 to 6, if E is 2, 4, 6, then E naught, so you kind of have to think of, I'm going to cross out 2, 4, and 6, because that is what E, what is in E, so whatever is left is 1, 3, 5, okay? It could also be E naught like this. It's the same thing, 1, 3, 5. In general, NE plus NE naught is equal to the universal, always, okay? Evens and not evens would be our universal. And so from this, we can deduct this one. This is, for me, the most important one, this one right here. If you want the complement of an element of a set, just take the universal and subtract E from it. And then you've got your not E, you've got your complement, okay? We're not going to draw the Venn diagram, we're just going to continue. So let's go to 4, page 4. And I'm sure you, if you watched it, you know what I'm talking about here. But maybe it doesn't hurt to do this, to see this another second time, okay? Sets can be expressed in 3 ways. Words describing the elements, actually listing the elements, and a Venn diagram. So let's assume there's a small class of 10 students. That's our universal. So this is 2, 4, 6, 8, 10. So this is my universal set right now. Do you see that it's called A? Right? That's fine. But this is my universal. G is students in grade 12 applied wearing glasses. Okay, so these are all the students wearing glasses. B are students that have blue eyes, right? So there's 3 students with blue eyes. So out of my universal, I've created subsets as follows, okay? So we want to draw the corresponding Venn diagram. Before you start, scan your sets, right? Is B perhaps a subset of G? Is it possible? Let's see here. Chip and Chip, right? Jenna and Jenna. But Xenia is not in there. Do you see that? Xenia is not. So they're not subsets. What that means is you're going to have some overlap. Some overlap is there, but you're not going to have to nest one inside the other. Okay? So this is my set A. Just put A out there. This is set G, and this is B. Before you write anything down, I would check what do they have in common. So I'm going to highlight that. Chip goes with Chip, and Jenna goes with Jenna, right? So those two are shared. So I'm going to put that down here. Chip and Jenna. Okay, these are the ones that are shared, therefore these sets are joined. Okay, and now I fill in what's left. So Biff, Damien, Fernando. And for set B, I haven't included Xenia yet, so Xenia is going in as well. But please don't forget about your outliers. Just don't forget about the outliers, okay? Just in life, don't forget about the outliers. Always look around, like who's not being included and try to include them, right? So we look at, and so Anna is not part of any of them. So you go Anna. Biff is also part of the outliers. No, Biff has already been used, sorry. My bad, I caught it. Chip is already being used. Damien is already. Dimitri is not part of any of the sets, so therefore an outlier. Fernando's Gurjot. Jenna's already in one of the sets. Joel is not. So Joel goes on the outliers. Xenia is already. Okay. So this would be a proper Venn diagram with every element listed. Before you're done, make sure you count how many? How many in our Venn diagram in total? 10, right? 10? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now you know you're probably on the right track. Okay. So I will introduce something new to you. I don't know if you've watched this in the video. I don't know if I did it in the video, but we start to actually tell ourselves how many elements are in the universal, and there's 10. This is going to be very handy for what we are about to do. In B, how many elements are in B? There are 3. I can observe it in my Venn diagram. I can observe it if I just count the listed elements. There are 5 in G. Okay, and so that's kind of where we're going to stop for now. Okay, and then we can ask a bunch of true and false questions. Right? Is G a subset of A? That is true. We're not going to explain here in this paper, but any subsets that are inside A, they're going to be, sorry, any sets that are inside of A are going to be subsets of A. So is B a subset of A? Yes. Is G a subset of B? No. Because all of G needs to be in B as well, or so it doesn't work. And I will actually explain this one. Not all elements in G are found in B. Is B a subset of G? It's also false. Same rationale. Okay. Can I ask you, based on what I've just done, I mean, you may have filled this already in, but I would like you to give this a go. Let me just zoom out a little bit so I have my Venn diagram. N of U, I already told you that this is 10. N of G, I already told you that this is 5. N of B is 3. What about N of not G? There's a couple of ways. I would like you to start thinking NU minus G. That is 5. So I go universal minus G gives me the complement. N of not B, it's B is 3, so it's 10 minus 3, that's 7. However, please also remember you can go and cover up B, and everything that is remaining is not B. Every single element that remains is considered not B. Right? In each case, state whether it's finite or infinite. What would this be? How do you know? No dots. Okay. What about this one? Infinite because of the dots and one of the ends, right? Yeah. So what would it be if I asked you for N of D? 3. What about this one? Ooh, infinite. Or did I said NA, right, in my notes? I would say both are okay. I've never seen this on an exam. So, or just say NA, yeah. There's just no way to tell the actual number, okay? Okay, keep going. Did I talk about the deck of cards in the video? What deck of cards, Mr. Dixon? I have no idea what you're talking about. It was in the video, I'm pretty sure. Okay, I'm gonna give you a shortcut. I don't know if you wrote this down or not when you watched the video. So please just follow along, okay? A deck of cards in total has 52 cards. Okay, that's my universal. There are 26 black cards, and there are 26 red. Okay, you got that? Every suit has 13. There's 13 clubs, 13 spades. Am I getting those right? Okay. There's 13 hearts. There's 13 diamonds. Thirteen of each suit. Are you familiar with the terminology, right? There's 4 suits, 13, 4 times 13, 52, okay. What are these ones called? The combination of, everyone has the queen, jack, and the king. Combined, we have face cards. So faces, there's 12 faces. And therefore, there is 36 numbered and 4 aces. I don't think you should have a whole deck of cards on your study sheet. I think that would be too much. That's too much. So I can give you a little cheat for this are you interested or interested? I give you this visual so that at least if you're not into cards, if you don't play cards, then it's hard to visualize this. So what I will do is this. I'm going to try to fit it into a small area. So 52 cards, 26 are red. You can make this even smaller. You can make this smaller, right? 26 are red, 26 are black. You've got 13 diamonds, 13 hearts, got 13 spades, 13 clubs. For each one of them, you have an ace. You have numbers 2 to 10. And you have a jack, queen, king. Just on my desk there somewhere. I don't know if you need this every single time. Ace 2 to 10, jack, queen, king, ace 2 to 10. I don't know if you need this for every single line. Ace 2 to 10, jack, queen, king. You should be able to tell me, just by looking at this, how many kings are in that deck. There's four Ks, right? So 4 kings. There's 4 queens, 4 jacks, and so forth. You should be able to tell me that there's 12 faces. So if you need to write down under here that these are the 12 faces, get creative and try to add that to your study sheet. So please make this smaller. If you can, just compress it. I know some of you are really good at it. You're just gonna have to work with that, like leaving almost no space in between. But if I made it too small, you couldn't see it. You couldn't read it. Okay, you're good? Don't be so serious. It's all good. It's gonna be all right once we get going here. Today's a little dry. Okay. Study sheet material, this one as well. I would not have the diagram. I would just make sure. Let me see what I have here. I don't know what I did in the notes, to be honest. They do ask, the province has thrown like, hey, these are prime numbers. It's the prime numbers from 1 to 10. Do you know your prime numbers? So the prime numbers here, there'd be 2, 3, 5, 7, 11. What's the next one after 11? 13? So if you need more than that, I'll just say, where would I fit this in? I'm gonna try here. Prime are only divisible by 1 and itself, right? So one thing that is interesting about prime numbers, hold on, I can't do 2 things at the same time, 17, 19, 23. I'm gonna stop there. I don't think that you're gonna need more than that. One thing about prime numbers is you can't say they're all odd, can you? What's the one anomaly that makes it also even, part of the even set? It's the 2. All of them will be odd. As far as we know, they're all odd, except for 2, which is even. So that makes prime a special case, prime numbers. So know your prime numbers, have that on your study sheet. So if I go back up, sorry about that, right, you should know what your natural numbers are. It's whole numbers starting at 1 going to infinity. Whole numbers include the 0 going to infinity, so no negatives. Integers, now you're going into the negatives as well. Whole numbers going into the negatives. Real numbers is really everything you can possibly think of. And then prime is the other one that I need you to have, okay? So that's that. Keep going. I'm going to take you to 10. 10 is the one that right now, after the terminology, I really need you to be familiar with. If I run out of time, guys, page 8, I would like you to try page 8. So homework already. Page 8, the key is on page 9. So if I run out of time, that's where you're going to go. That's the one I would like you to try for before tomorrow. I'm going to stop here once and